Good day, everybody, and welcome back. I'm just going to start by talking about the uh, code test bed that we were looking at in the last video. One thing I forgot to show is just to actually activate it. In our particular example, we have it by default set to look for two pair. So here we can see in the console that it found the two pair. Um, if you go through here, you can see each time. So it found one two pair at the end, first found, and then it displays it, shows the modifications, etc. So it's all text output. Um, if anybody went through and started modifying everything, they'll notice that all of the prints, print statements in some cases, some of them will be broken unless they change, for example, the kicker to refer to the dictionary. But we're going to get more into that in here. So the easiest way, if you're trying to do new things with this to test it, is to change the cards that are being fed into it in order to determine what type of cards it is. The easiest way to test would be sequentially from the top down as far as what cards get assessed. So straight flush, then quads, then boat, then flush, then straight. Which I already have default sort of values put in there to test, but obviously there's many different scenarios for each one. A full house, uh, as an example, could have aces, which is in this case, so you might want to test that the aces get properly evaluated, etc. Um, but yeah, that's basically how you would use a framework like this. Now we're going to move into moving all of this into the project with the modifications I lightly touched on in the last video. So some of the more observant of you that might have happened to download the updated project in the last video might have noticed that it had more functionality. The functionality I added to that video is actually what we're going to be covering now. So basically what we're going to do is we're going to take the poker logic we discussed in the last video and we're going to start implementing it, and hopefully that will improve understanding for how it integrates. First we're going to go into our main script here, and we're going to create an area for calculating the poker hands. So I'm just going to make it easier to spot by putting right here poker logic, and down here we'll put what should we call these? Signal functions, I guess, for what's below it. So the first thing we're going to do is we're going to have to change our game loop slightly. Let me just look at the reference project. We're going to add a new part to our game logic where it evaluates the hands. So we'll create a new enum with poker evaluate in it. And then after that, we're going to have to add a couple of new variables. And poker calculating, basically, this variable is just going to be a Boolean, just for the loop, because it's going to be in it's going to be in a function that's calculated under process delta, which is calculated every frame. So we definitely don't want it to keep trying to calculate hands once a hand is already being evaluated. And then of course it'll switch to a different state after that. So that's what this variable's for. And again, for controlling the flow, we use these booleans just so that we're not doing too much reiterating over stuff that we don't want to reiterate over top of. That's what these variables are for. And the next thing we're going to add are the dictionary variables. Dictionaries are a complex data type, kind of like an array, but they can contain multiple types of values in them. So, for example, the player poker data is going to have something called string. So on the left side in this particular formatting, these are the keys. So these are how we pull this information, is by asking for this key, and it will give us these values. So as you can see, we have a string for the player name, which if we're being clever, we could actually grab this from the actual player and enemy hand scripts, because you can see we have a player name on the right there. But I'm not doing that right now. If you feel like it, go ahead and add it in. It's a relatively simple task. But as far as that goes, everything here, we have these arrays and these integers, that Boolean value, and that string. So the important thing to remember is that Godot uses, with its complex data types, they are always referred to by reference. And what that means is that if I was to create another variable and have it equal to player poker data, then it would actually be a reference to this dictionary. So that means if I, in the second variable that I theoretically create, if I change the value of name, it will change it in player poker data as well. So that wouldn't happen if it was a simple variable like an int. So if player poker data was equal to 1, and I made another thing called enemy poker data and set it equal player poker data, on initialization it would equal whatever the value was in there. But if I changed the enemy poker data to 5, it would not change player poker data. And that's not the case with dictionaries as a whole. But that can actually give you a false sense of security, because if, for example, I refer to player poker data and the hand rank dictionary key, which equals 0, because that is an int, if I try doing that same thing just by referring to that value instead of the dictionary as a whole, it will act like an int. In other words, it will be passed by value, not by reference. So that's important to remember, and we'll see why in a little bit. So that was a mouthful for that. As far as this stuff goes, we have to go and add a poker evaluate into our state machine here, our simple state machine. And for poker evaluate, we're going to make sure that the enemy reveals cards, which is a function we haven't added yet. So it's going to check to see if poker is calculating. That's that Boolean value that I was talking about. So by default, it's true. But this is to make sure it only does it once, which is why it changes to false at the end. In theory, once we get to the end of the card poker winner, or calculate poker winner, at the end of that function, it will change our state anyway, so it won't come back here and try to iterate through here. But this is basically to make it so that it's not just constantly trying to evaluate the cards over top of each other, causing like an endless loop and causing all sorts of effects we don't want. So the first function we're going to use is this reveal cards, which we have not created, and it'll be unique to the enemy hand. So I actually did this in kind of a goofy way in retrospect, so I'll show you what I did. Basically, if we go into, if we remember our enemy hands, the function initialize cards actually overwrites the initialize cards that's used by all hand things, because the enemy hands inherits from hand, right? So it already has an initialized value, but the biggest difference between the enemy hand and the player hand is that we don't change the sprite to anything. We make it so that it changes it so that you're looking at the back of the card instead of the front. So as you can see here, it changes it the card back. But we can see that we actually have all of the logic still there so that the card knows where its front sprite path is. Now, when I decided to create the reveal cards, I forgot about this. And so I have it do all of that over again. And it then creates the change sprite part. So that part's actually not needed. I do not need to use that at all. So I am going to scrap this part here. Oops, my mouse is a bit wonky right now. And wait, half a second here. So where's the value here? Right, so I'm in the wrong one, that's why. Enemy hand. So I won't need this part here at all. And I won't need this or this either. I'm just going to comment them out for a second to work with. So I want it to actually change the sprite to front sprite path. Since I already made that value. So if I didn't forget anything, that should work and do everything that big loop that I had in there was. The additional thing too is that because I'm displaying the two cards, the whole purpose of the reveal cards to show the two whole cards that the enemy has left. I had to figure out where I wanted to display them. If I just flip them where they were, they overlap and they're hard to read. So I'm going to move the cards. First, I'm going to set the unit offset of the path follow 2D, which is the thing that we use to determine where the cards get laid out when it fans them out. So I'm going to use this point here and this point here to display the cards, and I'm going to increase their size so that the scale is the same as the player's card, and then I'm going to move them up slightly. So the way that gets done in our script is that we change the offset of the path follow 2D using the unit offset, which goes from 0 to 1. So the start, which is the far right, will be where the first card is, which is hand 0. And we're going to move it to the global position of the deck spawner. But we're going to add a vector 2 for a -50 on the Y. And that will raise them up a bit because negatives on the Y equal moving up. So those should be pretty straightforward, and that part is done. Now, back to our main script where we're adding all of this poker logic. So the enemy is going to reveal its cards. We're going to change the data by using a get hand functionality, which we have not added yet. I could actually just go player.hand and it will grab that variable, but it's considered not a best practice, so we're going to create a function to do that. So this is a really simple function, simplest one we'll do. If we go underneath initialize, we'll put it here, or I guess we'll put it after place hand. So that's all it does. It returns the variable hand, which is the array that contains all of the scenes that contain the hands, the cards. All right, so now that we've done that, going back to main, after it's done all that, obviously it wants to do evaluate hand, which does not yet exist. So we're going to make that. So going all the way down to here, we're going to start adding this stuff. So the evaluate hand is based off of the exact same one we did in the sample that we were showing in the last video of the test data. There's all these extra print statements in here which aren't required per se. They were just used for testing. Anytime I use the print value card values or print statements, it was always done for testing. So I like kind of leaving them in and comment them out when I'm not using them. You can feel free to do that as you see fit. So as you can see, because if we look at our original project, which I don't have up right now, but before it actually had a variable called hand rank, which referred to in the test it actually just had a variable called hand rank, but we're going to use the dictionary that gets fed into evaluate hands, which will identify the player, etc. So it's going to do the exact same functionality. It's just going to keep checking to see if the hand rank has been chosen to a high number and going through. So if it detects a straight flush, it will not do any of these. If it detects a quad, it will not do the rest of that, etc. So now feeding through the calculate poker winner, we're not going to quite get there yet. Let's go through the separate evaluations and the differences in this. So the build card combos function that we did before works exactly the same, unchanged as our demo, uh, doing every possible combination of the 7 cards that get fed to it, and returns a hand, which we can then analyze one by one. So after that, the important thing to remember here is when we're doing this stuff, like the straight flush check, is we can't, we can say variable best hand equals dictionary best hand, and those are passed by reference. So if I do changes to best hand, it will transfer immediately to the dictionary best hand value. So, but the problem is that we can't do it with any of the integers, which is critical because, for example, hand rank is an integer. So the only way to fix this, my initial attempt to fix it was to just add the variables and make it there, thinking that because it was a dictionary, it was passed by reference, but it is not because those values are integers within the dictionary. So as soon as I make that equal to an integer, it no longer is passed by reference. So we have to access them directly. So yeah, that's the biggest changes, is having to manually go through to any of the integer type values that are referring to something that's in the dictionary and access them directly by using dictionary, square bracket, name of the field, and square bracket. If we don't do that, then the hand rank, as an example, will remain 0 all the way through the loop and nothing will work, and it will always be a draw and it won't print anything properly. And that pretty much carries out to all of the other logic. So I'm just going to quickly copy and paste that stuff in. Since we discussed it to death in the last video, I'm not going to go through how the logic works. But again, the biggest changes was changing all of the variables to the dictionary value, with the exception of things like the player name. And yeah, that's basically it. Just give me a half second. This is a lot of code and I want to make sure I don't grab too much of it. All right, so here's all of our evaluation statements and they should be good to go. The one thing, I know that there's an error in my code and we'll probably find it shortly. So these are all the exact same things. Again, the only major differences between this and the code we were looking at last video is that I added all of these. Let me see an example here. These variables that determine, sorry, up here. So high cards started, that one was already there, I believe. But these dictionaries for best hand, etc. Originally, I had ones for the main value, second value, kicker, and force value. But as we discussed, because it's not passed by reference, it was useless to me. It would have been really nice if it worked because it would have saved me a lot of typing of changing all of these values. All right, so now we get into the calculate poker winner, which is the simple logic we're going to use to make determine the winner, basically. So calculate poker winner, my advice when you're making this kind of thing, because dictionaries are sometimes hard to remember what the values are, is to just copy and paste the actual dictionary in as a comment while you're working, so that you can refer to it to remember what all the keys are named. So ultimately, to calculate the poker winner, we have to look at the two dictionaries. There's no need to pass them into the function, because there's only ever going to be two players in our current game design. So those two dictionaries are there, and then it's quite simply going to declare using the send alert function um, who has the better hand. So it will do that using the determine hand rank, which is going to be the next thing we're going to go through. And basically, it goes through each value. So it's going to start with the main value, or sorry, yes. Um, yeah, it's going to start with the hand rank. It's going to go next to the kicker, and then, or sorry, it's going to start with the hand rank. It's going to go to the main value, then the secondary value, etc., until it's determined who's won. So after that, it will basically, this function's where determining the value of the card is, and it will first compare the hand rank, and if the player has the higher hand rank, then he wins. If not the enemy, then it will do the main value, then the second value, then the kicker, then the fourth card, and then the fifth card. And then if it's gone through all that and hasn't found a winner, it will declare a draw. And notice I use all small caps. That's basically because of the restrictions of the font I'm currently using. So the calculate function, sorry, the determine hand rank is the next one, and it's pretty simple too. It's just going to basically figure out a way to write this out as a text, and we've done this before, but basically it's going to look at anything that has a non-standard value. So 10, 11, or sorry, 11, 12, 13, and 14 are all jack, queen, king, and ace. And then it's going to look at the rank and determine what it is as far as the string goes. So a royal flush, straight flush, four of a kind, full house, flush. And we could make this more complicated if we wanted. We could come up with a system that probably determines if there's a tie between the enemy, and if it is, we can have it print additional kicker information so we know why. For example, if it says player has a full house, enemy has a full house, player wins, that might be unclear in the UI why somebody won. So we might have to say it a full house, aces and kings, and the enemy has a full house, jacks and sevens. Or more likely jacks and kings and jacks or something like that, then it would make it more clear to the player as to why one full house is better than a full house. But for now, we're keeping it relatively simple. And yeah, the only exception is for the trips and fours or whatever, and the pairs. So we might as well put the value of whatever those cards are, and same with high card. But yeah, there's times when it would be nice if it went all the way down to the kickers, just for clarity. The one thing too that I want to go through before we get into displaying everything is I want to fix our UI. So the way our UI works right now is that when we send an alert to it, it will just display an alert. But the problem is that in order to make it work without it going all wonky, is that right now we have it so that it stops before it plays. So if we have 5 alerts all come within like a nanosecond of each other, the last one's the only one that will get played. So ultimately, this system only allows one animation to be going at the same time. And there's a couple of ways to manage this. We can create it so that there are multiple animation players, so we can have multiple animations going at the same time, but based on that would be even harder to read. So we're going to take the other approach in that we're going to queue them all up into a variable, and we're going to pull them out as we need them from that variable. So we're going to start out by adding adding a variable called message queue, MSG QUEUE equals square brackets, so just a blank array. And for send alert, we're no longer going to do this. We're going to take all that out, and we're just going to append which is a function for arrays. So we're basically adding whatever message got sent to this array. So to display it, we're going to use process. Oops. And we're just going to check to see if the size of the message queue is greater than 0, and if the animation player is playing, we're here. Anyway, I'm not sure why that's there. Just a sec. It's fine. Oh, sorry. If the message queue size is greater than 0, and then we're going to check to see if the animation player is playing. And so if the animation player is not currently playing, then it will change the text to whatever it says at message queue in the first array element, so message queue 0. And sorry, somehow I screwed that up. $sign. There we go. So after it's determined that that isn't there, it's going to add our message to the queue. From the queue into the text of the alert. And then immediately, since we've added the text, we don't need it anymore. We're going to remove that element from message queue. And then after that, we can play the alert. That'll be the animation that causes the text to appear the same way we had it before. And before we move on to the next one, as an extra buffer, this is actually probably redundant, but it doesn't hurt. I don't think it makes it more inefficient anyway, but it's going to make sure that the animation player has stopped before it continues. So yeah, that's what that yield statement does, is it makes sure that the animation finished has happened before it carries on. So basically, if I have 50 messages waiting in that queue, it will go through them one at a time instead of ignoring the first 49 and only printing the 50th. So that should fix that. Now, let's see what we broke. So we should see that these work a lot better now, because there were a few situations while we were testing where they didn't work all that great. As far as UI goes, again, this isn't necessarily the most readable thing for some of the outputs that we're going to get, like comparing the hands and stuff. And oh yeah, okay. So we haven't fixed that part yet. So the loop is wonky and going into game over and over and over again. So let's find the game over bit. Oops. Main. So yeah, end round's being called too quick. So we're going to go down to our signals and we're going to change the end war timer. And we're going to change this to poker evaluate. And that should do it. All right. Player has a full house. Enemy has a pair of kings. Yeah, pair of kings. So we win. So that's good, except that I expected those to increase in size, so I missed something there. But overall, it works good. It actually looks like the dude has both of them in his hand, so we could actually keep that how it is. And it would actually look pretty funny, even though nobody would show their hands like a child with one card in each hand, I don't think very often, but yeah, I kind of like that. I might leave it, but obviously in the enemy hand reveal cards function, if we wanted to, we can change the scale, so we could add this line if we want. It has to be in the loop, so yeah. Oops. So since we have a quick game loop here, I'm not going to bother hacking it to make this faster. There, so we can make it bigger. Anyway, we can tweak those settings as we see fit. It says we have a draw. Do we have a draw? Pair kings, pair kings, pair nines, ace. Yeah, so we got a draw. Right, so everything seems to be working there overall. Obviously, like we could tweak it. We could either make these so that it's maybe 1.5 instead of 2, so that it doesn't clip underneath these, or we could make it so that it comes forward, so that it covers up the cards below it. But for now, we'll just leave it. It's the least of our worries. So on the next video, I figure that what we're going to do is worry about tweaking bugs, basically. So we're going to try to debug this a little bit. We're going to solidify our game loops so that it's a little bit more clear and usable. And that will probably be the last video we make on this, unless I decide to expand upon the project for some reason. There's a lot of like little housekeeping things that I probably won't do, like how these cards clip into the UI. I could probably make it so that the cards either go over top of it or just move this over slightly, but it's a good example of a housekeeping thing that I'm not going to cover on this, so you can pretty up your project as you see fit. But my goal is to, on the next video, make it so that we have a solid game loop, and so that we make it so that it has functionality so that it would work as a mobile game, so that the touch inputs work, and yeah, basically make it so that the game loop goes through and restarts back into playing. Ultimately, it could be expanded so that you could have multiple different enemies that you fight that all have different characteristics in AI, but I'm not going to worry about a poker playing AI because the poker logic was hard enough to develop. And it goes beyond how far I want to take this project right now. So I hope everybody's kind of learned something about, making a card game anyway. And we'll see you on the last video, and which will hopefully finish up everything that we need to do. Thanks very much, and feel free to give it a like or a subscribe if you're enjoying yourself.